All right, so given two terms in a geometric sequence, find the explicit formula of the sequence. So it says geometric, so because it says geometric, I want to use the geometric formula. And so the geometric formula, I'll just write it over here, is a sub n equals your first term times your common ratio to the n minus 1 power. Now what it gives us is the term and then what that term equals. So basically it gives us what the n is. In this case the n equals 5, and then obviously the a sub 5 equals 300 or 3,888. So I can write those two statements with my a and my r as the variables that I'm looking for. So 3,888 equals a times r to the n minus 1. And then my second one is going to be 108 equals a times r to the n minus 1. Now I can simplify that to the fourth and then squared. So now we're going to use substitution for us to be able to solve these. In substitution, we can get a variable by itself. So for example, I can divide both sides by r squared here. So I get 108 over r squared equals a. So that means I can substitute that in for a here. So I'm going to get 3,888 equals, now instead of a, I have 108 over r squared, and that's times r to the fourth. Now some of the r's are going to reduce, so I get 3,888 equals 108 r squared. Now I can divide both sides by 108, and so that's going to give me 36. And now I can square both sides, square root it, and you do get plus or minus 6, but in this instance it's only going to end up being a positive 6, so we just have positive 6. So that's my r. So now I can plug r into one of these equations that I established here to find what a is. So for example, I can plug it into this one, 108 equals a times r squared. That's 36, so divide both sides by 36. You should get a equals 3. So now that I have my r and I have my a, I can write it as a sub n equals a times r to the n minus 1. So the key there is substitution. This next one, it says given two terms in an arithmetic sequence, find the explicit formula. Okay, so arithmetic. So my arithmetic sequence is a sub n equals my first term plus n minus 1 times my common difference. So same idea, n here is 18, and then it gives you the a sub n. So then you get 44.3 equals a plus 18 minus 1 times your common difference d, because we don't have those. And then the next one is 84.8 equals a plus 33 minus 1 times your common difference d. So you get 44.3 equals a plus 17d, and then you get 84.8 equals a plus 32d. So now again, we're going to use substitution to help us here. So I can solve for a. I can subtract the 17d on both sides. And so I get a equals 44.3 84.3 minus 17d. So now I can substitute that in for a into my other equation. So I get 84.8 equals 44.3 minus 17d plus 32d. I can bring that to the other side, so minus 44.3, and that's going to give me 40.5. And then 17 and 32, that should equal 15d. So now divide both sides by 15. And this you're going to have to use your calculator for. You get 2.7. So now I can use that to find my A. So I can plug in D, let's just say into here. So you get 44.3 equals A plus 17 times 2.7. So that's 45.9. And then you subtract the 45.9 on both sides, and then you should get negative 1.6, and that's equals your A. So then, writing my formula, A sub n equals my A plus my n minus 1 times my common difference. It says, given the explicit formula for the arithmetic scheme, find the first 5 terms and then the named term. Okay, so the first 5 terms is plugging in 1, plugging in 2, plugging in 3, plugging in 4, plugging in 5. So those are the first 5 terms. So if I plugged in 1, that's negative 11 plus 7, which is negative 4. If I plug in 2, that's negative 11 plus 14, which is 3. If I plug in 3, negative 11 plus 21, which is going to be 10. If I plug in 4, that's negative 11 plus 28, which is 17. And if I plug in negative 11 plus 35, that equals 24. So those are the first 5 terms. And then now it says find A of 34. So then the last thing you're going to do is find A of 34, which is negative 11 plus 7 times 34. We'd have to use our calculator for that. So that's 238, and then plus negative 11. So that's 227. So then the next one, given the explicit formula, find the first 5 terms. So A sub 1, A sub 2, A sub 3, A sub 4, A sub 5, and then find the 7th term. So then also A sub 7. So you just plug them in. Three to the 2 minus 1 gives you 3. 3 to the 3 minus 1, that gives you 9. 3 to the 4 minus 1, that gives you 27. 3 to the 5 minus 1, that gives you 81. And then, see, that's 81 times 3 times 3. So that's 729, because you can do 3 to the 7 minus 1, which is 3 to the 6 power, and that's going to be 729.